Hey guys, sitting down here doing this practice problem, okay? Now, I'm showing you my notes because again, I'm just gonna transfer this information. Hopefully you'll take a look at the question, pause it, give it a try on your own, and then see how you did, okay? So let's start. First, we know we're going to have to state, plan, do, and conclude. So we might as well. Oh, and then this one, so for part A, we're gonna have to state, plan, do, and conclude to get our 4 points. And I can think of this as 1 point. This isn't exactly how the AP grade it, but you can think of it like that. Okay, so I need to section this off. So maybe something like that. Right? So I need to state, plan, do, conclude. If I'm going too fast, you can slow down the recording to any speed you want. And then this is part B. Okay? So first it says state, we will perform a 1 proportion Z interval to find the true proportion of adults who can roll their tongues. All right, when I read this question, it says, in a recent survey of 1,500, 68% agreed I should exercise more than I do. Construct and interpret this confidence interval to estimate the proportion of US adults that would agree with this statement. Okay, so I'm gonna pretty much say exactly, just word for word. We will perform a 1 proportion, so what is it? 96% confidence interval, Z interval, to find, what is it we're finding? The proportion of US adult population that would agree with this statement. The proportion of US adults that would agree with the statement, I should exercise more than I do. I should exercise more than I do. Now I did something a little bit different than I normally do. Normally I copy exactly that, but I always want to talk about the context. The context of this problem is about exercise, so I need to talk about exercise. I don't want to leave that out, right? Probably wouldn't be wrong, but it would be wrong to your boss if you were doing this for a living. All right, so we stated. Now we know what the conclusion part's going to be. State, plan, do, conclude. In this instance, we're going to be 96% confident that the interval created from our calculator would capture the true proportion of adults who agreed with this statement, I should exercise more than I do. So I'm going to go ahead and write that. We are 96% confident that the interval from blank to blank, we'll get our calculator to tell us that, captures the true proportion of US adults that agree with the statement, I should exercise more than I do. Okay. Cool. So let's get a calculator to create these. Now we have to get our calculator to do it, but we also practice just using something at home. So here's my iPad. I'm actually not typing on my iPad today. Right? And I Googled the term confidence interval calculator for proportion. If you don't add the word for proportion, then you might do a means question. So go ahead and Google confidence interval for proportion. And I noticed a website I've used before because it's already highlighted. It says Stats Kingdom. I think I like this one, proportion confidence interval calculator. Beautiful. Okay, so make your way to this website. Pause it if you're going to take a minute to get here. So notice it's the site Stats Kingdom. And it says digits, confidence level, sample size, success. So this is a little tricky. They're making me do a little bit of math here. I don't know how many people said yes. So looking back at my problem, if I think about this for a minute, I only know 68%. So what is 68% of 1,500? And of just means multiply. So we multiply this, right? So I do need to go to some kind of a calculator to figure out how many, wait a minute, how many people said yes? What is 60.68 times 1,500? Okay, so that means 1,020 said yes. Okay, so this is equal to 1,020 over 1,500. Now you can double check this. 1,020 divided by 1,500. Yes, that's 68%, right? 1,020 divided by 1,500, 68%. Okay, so back to our interval calculator. This digit just means how far out do you want a digit. So I really probably only care to a 2 or 3, but I'll set it on 4. It said my confidence level would be 96. Okay, my sample size 1,500. And the number of people said, yes, I'd agree with that. I need to exercise more than I already do. So that's my information. That's all I have to tell to my calculator, and it can do everything else. So I'm going to hit the calculus test. And what's really neat is I love how some of these websites really lay this out here. I was trying to explain some of this in class. So this is the 5% of the area, or not 5%, now it's 4. So 2% and 2% is outside, and this area is 96%, right? So I get the estimate, the probability of success, and ooh, this is giving me some, using normal approximation, which is what our calculator would do. So there's some other mathematicians that, oh, it's interesting. They're like, use this one, but we're going to go ahead and use the one in the middle. I get 0.65. Notice it barely matters which one I use, but I'm going to move this to 2 digits, so I don't even have to round. I'm just going to list 2 decimal points. Yeah, so depending on the method, you're essentially getting the same outcome. I'm going to put 66.66 to 0.70. Okay. So what else should the calculator give me? Notice it gives us the point estimate and the margin of error, right? The point estimate and the margin of error, right? So the point estimate was 0.68. We already had that, plus or minus 0.025, okay? That was actually a margin of error we had in class. So we're gonna state, plan, do, and conclude. Each one of these we got already from our calculator. All right, so now I can either do the plan or I can do the do. I've finished the state and the conclude. So I'm just gonna do the do. This is the same formula I need, so I'm gonna copy it over here. P hat plus or minus, so my point estimate plus or minus my margin of error. My margin of error is my Z star, times P hat, 1 minus P hat over N, and I take the square root of the whole thing. All right, so taking my P hat, we know is 0.68 from our calculator, and because it was given, Z star. So if we look in our notebooks, our Z star was, what is my critical value when I'm doing a 96%? So I'm using this number, 96 to 2.054. Okay, 2.054 is what I'm going to use. So 2.054. And then this is 0.68. So 1 minus 0.68 would be 32 over, I talked to 1,500 people. All right, now the calculator did all that and says all that is equal to that. All right, you can check it if you want, but again, that's what happened in class, and that margin of error, if we add it and if we subtract it, it creates this and this. Make sense? Okay. So our last step is plan, and then there was actually an extra part here. So we have to do our plan, and then we have to do our part. So what is my plan? Well, I remember R and I to make sure I get each component. So we need to make sure that when they asked these 1,500 people that they did so randomly, they need to make sure that the number is sufficiently large, which is definitely big, 1,500. And then we have to ensure independence. So the 10% condition states it has to be large enough of a population that your population you're interested in making an inference about is at least 10 times greater than N. So we know our population of adults is more than 15,000. Okay, so we're pretty much set for all these, but we're going to go ahead and we have to write them out to get our points. So R, N, I. R stands for random. So we're going to say yes. It says right there. The sample was taken randomly. Okay, we're okay with that one. Number 2, N. What is the number? Did we ask enough? Was our number big enough? So N times P hat has to be greater than or equal to 10, and N times 1 minus P hat has to be greater than or equal to 10. So that's the number of yeses and the number of no's. We already have calculated that. That's how many yeses, and the number of no's would be 1,500 minus 1020. So you're like, well, why are you subtracting? Why aren't you using these formulas? I totally can. This is faster for me, right? So N is 1,500. When I multiply 1,500 by 68, which we did, we got this number, 1020, and that's greater than 10 for sure. And then this number, 1,500 times 0.32, should get the number 480. And that number is greater than or equal to 10. So this condition is met. So my test for independence. If you were sampling these without replacement, which we were, we just have to make sure that using the 10% condition, so I'm going to say 10% condition is met because 10 times N, which is equal to 10 times 1,500, which is equal to 15,000. There are more than 15,000 adults in the U.S. population. Okay, so we're safe for all the conditions. Therefore, we did our formula. We created an interval. Our interval was 0.66 to 0.70. And we interpret it in the context of the problem. Okay, so now we're going to do part B. They snuck in an extra section. For this study, state one source of potential bias. So this tells us we'd consistently get more or consistently less of a certain group or type of person or type of answer because of how or who asked the question. So for this study, state one source of bias. How would it affect the estimate of the proportion who would agree with the statement, I should exercise more than I do? So, there's a couple you could come up with. People have a tendency to lie about their workout habits. Just like we have a tendency to lie about our age the older we are, or, oh, yeah, I work out. I wouldn't say that. But then the minute you get done saying that, you go home and go, holy crap, I should really work out. So this is called response bias. People have a tendency to lie about their workout habits. Which may lead to consistently getting people to underestimate. Agreeers to the statement, I should exercise more. Okay, now you could probably equally argue the other way around, but again, they said 68% of people said I should exercise more. Yeah, I'd agree with that. People may have a tendency to lie, right? This is called response bias. And yes, we want to say the name because especially on multiple choice questions, we have to name it. People have a tendency to lie about their work habits, which may lead to consistently getting people to underestimate those that would agree to the statement, I should exercise more. All right, guys, thanks for joining me. See you next time. Upload this to Canvas or bring it to class, one of the two. Thanks.